My name is Chinmay Salunkhe and my project topic for ELP 101 is Operational Amplifier. In this project, we are going to study and analyze the working of the operational amplifier. What is an operational amplifier? Operational amplifier is basically a multi-stage amplifier in which number of amplifier stages are interconnected to each other in very complicated manner. Its internal circuit consists of many transistors, FETs, and resistors. All this occupies a very little space, so it packed in a small package and is available as in the integrated circuit IC form. The term op-amp is used to denote an amplifier which can be configured to perform various operations like amplification, subtraction, differentiation, addition, and integration. Here is the diagram of an operational amplifier. We can see here that there are two inputs here and it is giving only and one output. Here are two supply, here are two terminals positive and negative from which we supply power to the operational amplifier. Working of operational amplifier. Open loop operation of an operational amplifier. As said above, an operational amplifier has a differential input and single-ended output. So if we apply two signals, one at the inverting, another at the non-inverting terminal, an ideal operational amplifier will amplify the difference between the two applied input signals. We call this difference between the two input signals as the differential input voltage. The equation below gives the output of an operational amplifier. V out equal to AOL V1 minus V2 is an equation for this open loop operation of operational amplifier, where V out is the voltage at the output terminal of the operational amplifier. AOL is the open loop gain for the operational amplifier. V1 is the voltage at the non-inverting terminal. V2 is the voltage at the inverting terminal. V1 minus V2 is the differential input voltage. It is clear from the above equation that the output will be non-zero if and only if differential input voltage is non-zero, and will be zero if both V1 and V2 are equal. This is an ideal condition. Practically, there are small imbalances in the operational amplifier. The open loop gain of an operational amplifier is very high. Hence, an open loop operational amplifier amplifies a small applied differential input voltage to a huge value. Also, it is true that if we apply small differential input voltage, the operational amplifier amplifies it to considerable value, but significant value at the output cannot go beyond the supply voltage of the operational amplifier. Hence, it does not violate law of conservation of energy. Closed loop operation. V out equal to ACL V1 minus V2 equal to ACL VD is the equation of this closed loop operation, where V out is the voltage at the output terminal of the operational amplifier, ACL is the closed loop gain. The feedback circuit connected to the operational amplifier determines the closed loop gain. ACL VD equal to V1 minus V2 is the differential input voltage. We say that feedback as positive if the feedback path feeds the signal from the output terminal back to the non-inverting positive terminal. Positive feedback is used in oscillators. The feedback is negative if the feedback path feeds the part of signal from the output terminal back to the inverting negative terminal. We use negative feedback to the operational amplifier used as amplifiers. Each type of feedback, negative or positive, has its advantages and disadvantages. Here we have two feedback, positive feedback and negative feedback. Positive feedback. When there is a feedback to the positive or input, this is called positive feedback and is used in oscillator circuits or used for hysteresis in comparator circuits. Because of the higher internal gain of the operational amplifier, when the positive input is more positive greater than the negative input, the output will be fully positive. When the positive input is less positive, then the negative input will be fully negative. Negative feedback. When there is a feedback from the output to the negative output. This is referred to as negative feedback and is commonly used in amplifier application. The most important thing to remember is feedback when negative feedback, operational amplifier will force the input voltage to at positive and negative terminal to be equal. This is the working of the operational amplifier. This is the end of the project. Thank you.